One of the best tools you can possibly own when beginning your journey into electronics is the digital multimeter, or DMM, or multimeter for short. Inexpensive models like this old Radio Shack unit offer just the basics. It can measure voltage, current, resistance, and continuity. To be honest though, that's really all you need for most of your circuit debugging and analysis. However, as you move up in price, you will expect better measurement capabilities as well as more features. But for now, I'm going to show you how to use the basics of a multimeter so you can get debugging your own circuits. To begin, let's examine the parts of a multimeter. At the top here, you'll see an LCD. That's where the numbers will show up to give you the measurement for whatever you're testing. Most multimeters will have a knob or some buttons that you can use to select what you want to measure. Here, we see that we can select various ranges for voltage, current, and resistance. We also have an option for diode and continuity tests. Note that the straight line with small dashes under it is the symbol for direct current, and the wavy line is the symbol for alternating current. At the bottom of most multimeters, you'll see a number of ports that will accept probes with banana plugs. COM stands for common and is generally connected to the ground or negative node in a circuit or component. Most multimeters will have another port with letters like V and omega. This tells you that you can plug in a probe here to measure things like voltage and resistance. This particular meter will also let you measure small amounts of current from this port, hence the milliamp symbol. For measuring larger amounts of current, you'll need to physically unplug the probe and move it to another port. In this case, it's the port labeled for 10 amps, which is the maximum amount of current this multimeter can handle before blowing its internal fuse. Probes with standard 4mm banana plugs will mate with most multimeter ports. Here we have several different types of probes. All of these will plug into a multimeter and can be useful in various situations. Regular probes are your general use case tool that have pointy conductive ends. To use them, touch each probe to an exposed wire, lead, or trace in the circuit. You can also find needle-tipped probes, which are great for getting at very small pins and traces on PCBs. Alligator clips let you attach the probes to a lead or wire to free up your hands to work on other things. IC hooks are similar to alligator clips and will attach to the legs of integrated circuits like this microcontroller. Finally, tweezer probes are great for measuring small components like this surface mount resistor. You'll often find that you need to measure the voltage between 2 points in whichever circuit you're analyzing. Before you begin, understand that in order to measure voltage, you'll need to connect the voltmeter in parallel with the component or components. This will measure the voltage drop between the two nodes without interrupting the circuit's operation. In our example circuit, we want to find the voltage drop across the resistor. To do that, we'll touch the positive probe to the node connecting the resistor and the LED, and the common probe to the node connecting the resistor to the negative terminal of the power supply. To create the circuit from the schematic, I've connected a benchtop power supply set at 5 volts to this resistor and LED connected in series. Now, we want to measure voltage, so plug your probes into the ports labeled common and voltage. The color of the probes really doesn't matter, but generally black means common and red means positive. Then, adjust the knob for DC voltage in the range we expect. In this case, we expect something between 0 and 5 volts. Having a maximum of 2 volts might be too low, so we'll select 20 volts. Finally, with the circuit on, touch the positive probe to the resistor lead connecting to the LED and the common probe to the resistor lead connecting to the power supply's negative terminal. As you can see, there is about a 3-volt drop across the resistor. If you accidentally switch the positive and negative probes, don't worry. It won't hurt anything, you'll just see a negative voltage on the LCD. Some multimeters, like this Victor, have auto-ranging capabilities. That means you don't need to select the range for your voltage, current, or resistance, just press the button for DC voltage. As soon as it makes a measurement, it automatically adjusts the range. All we need to do is probe the circuit and the correct voltage appears. I mentioned earlier that many multimeters can measure alternating current, or AC. That means we can see if outlets are powered. Before trying this, make sure that your multimeter can handle the voltage and there are no exposed wires. Also, make sure you only use one hand at a time to prevent current flowing through your chest if you do get shocked. Set the mode to AC voltage and a large enough range to see 120 volts if you're in the United States. Place the common probe into the neutral slot and the positive probe into the hot slot. You should see the multimeter show around 120 volts AC. Next, we'll see how to use multimeters to measure the resistance of components. Much like measuring voltage, we'll want to attach the multimeter in parallel with the component under test. The multimeter sends small amounts of current through the component in order to determine its resistance. As a result, make sure you disconnect the component from any live circuitry and ideally isolate it from other components, otherwise you could mess up the readings or potentially damage the multimeter. Let's say that we have a couple of resistors and we want to find out their values. The labels aren't there, they've been worn out, or whatever. We'll start by selecting the ohmmeter function and say 200 ohm max on the multimeter. Touch the probes to the resistor leads and we get a reading of 1. Some multimeters, like this basic model, can only display a 1 for the first digit, so this is how it tells us that the value is higher than our currently set range. So we move it up to 2 kiloohms and the same thing. Click the knob once more to 20 kiloohms and we see we have about a 3.3 k ohm resistor. Let's try this with another resistor. When we touch the leads, we get 0.0 something ohms, and this doesn't give us many significant figures to work with, so let's turn up the sensitivity, which is accomplished by turning down the range. On the 200 ohm setting, which is the range, we can see that this is about a 47 ohm resistor. Multimeters with auto-ranging capabilities will just tell us the value with the appropriate units. In this case, the Victor is saying that the resistor is about 3.3 kiloohms. Measuring the current draw of circuits is also an extremely useful feature, but requires a bit more preparation. Most importantly, you will want to break the circuit and add the multimeter, set to act like an ammeter, in series with the rest of the components. If you try to add it in parallel, it will create a short and you could easily blow a fuse or damage the multimeter. Many multimeters have a separate port for measuring current, so you'll have to move the probes. Since we expect more than 200 milliamps, we need to move the positive probe on this multimeter to the 10 amp port. Here, we have a motor to be connected to a power supply. To measure the current, we'll connect the positive terminal from the power supply to the positive probe and the negative probe to the motor. Note that I'm using alligator clips to make this setup easier. So, conventional current flows from the positive terminal through the multimeter, then through the rest of the circuit before returning to the negative terminal of the power supply. When we turn on the power, the motor spins, and we see it's drawing about 200 milliamps. Note that multimeters show you average current. Things like capacitors, inductors, and digital electronics may have instantaneous current spikes that you won't be able to see on a multimeter. So you'll want to use special current measuring tools and oscilloscopes to catch those. Much like in the voltage measuring example, if we swap the probes, we see the current appear as a negative value. This won't hurt the multimeter, but it does tell you the direction of the current flow. Once you are finished with your current tests, I highly recommend putting the probes back into the voltmeter configuration or just removing them completely. If you pick up the multimeter at a later time and attempt to test voltage without remembering to check the probes, you could easily create a short circuit and blow a fuse. One of the most useful features of a multimeter is its ability to test for continuity, and with this comes the ability to test the polarity of a diode. Just like testing for resistance, we'll want to probe a diode that's been isolated from the rest of the circuit if possible. The white band on this rectifier diode marks the cathode. Current can flow out of the cathode, but generally not into it. To measure this, we'll set the multimeter to measure diodes. If we touch the positive probe to the anode and the negative probe to the cathode, we'll get something to show up on the display. Here, you can see that it's showing about 0.57 volt drop across the diode. This means that there is a connection and current is flowing through the diode. If we reverse the probes, the display will show 1, which means that no current is flowing through the diode. Checking continuity is similar to checking diodes. The multimeter will let us know if 2 points in a circuit are electrically connected. On some multimeters, you'll need to select the diode mode and then press another button to get the audible beep. But on this simple multimeter, we can just select the diode mode and it'll beep at us anyway. The beep can be extremely helpful in quickly debugging circuits if you don't have to look up at the multimeter every time you probe something. Let's say that I have this TRRS cable and I have no idea which wire connects to which part of the plug. To solve this, set the multimeter to beep on continuity and touch the probes together to make sure it's working. Attach one probe to the tip and begin touching the stripped wires with the other probe. When I get a beep, I can mark that wire as being connected to the tip. I would then repeat this process to learn which wires are connected to the rings and sleeve. That covers the basics of multimeters, but some models have advanced features that might be worth knowing about. This Victor unit is capable of measuring capacitance, which can be very useful if you can't read or understand the markings on some capacitors. It can also measure things like frequency, assuming your circuit has a dominant frequency. And with a thermocouple probe, you can get temperature readings. Some built-in functions can let you store the minimum or maximum values and even send measurements over USB to be logged. Knowing how to use a multimeter can help you poke, prod, and analyze circuits. I always try to keep one nearby since it works as the first line of defense when debugging a design.